All right, page 113 in your textbooks. We've been working with signed numbers. Of course, any number smaller than 0 class is?
0.
Negative. 0 is? Positive. And if two numbers are the same distance from 0, we say they have the same absolute value. If they have the same absolute value, but they're opposite signs, like -4, +4, we would say those two numbers are? Additive inverses. And if we have two additive inverses and we try to add, water cup, if we try to add additive inverses, class, they will cancel to just give you 0. They goners. Otherwise, when adding signed numbers, if the signs are the same,
add and keep the sign.
Let's try that again. Now that we've all heard it, those who weren't quite sure what to say. If the signs are the same, add and keep the sign. In case you're wondering, Griffin, no, the poster's not up. They really do remember it that well. Add and keep sign. If the signs are different, class, subtract and choose the sign of the greater absolute value, or the winner. Okay, so one more time. If the signs are different, subtract and choose the sign of the greater absolute value. All right, that's what you were practicing in the homework last night, among a couple of other things as well. If you see a subtraction, do we ever really subtract, class? No, we add the inverse. Though there was things, it's not up there anymore. If I said, if we saw something like this, -12 minus 10, instead of looking at this as -12 minus 10, well, if we added the inverse, it'd be plus -10. Why not just think of this as -12, -10, -22, add and keep the sign. You could think of it that way, save just a little bit of time. We said if you've got a series of addends that are signed, what's the best approach to quickly and efficiently adding up a bunch of different signed addends? Kirsten?
Add all of the positives and then add up all the negatives and then add the answer that you get for the positive and the negative.
Good. Though technically, because one's going to be positive guaranteed, one's guaranteed negative, you're going to technically subtract, choose the sign of the greater. But yes, get your positive sum, get your negative sum, put those two things together. Just makes it quicker and easier. Let's go ahead and take a look at these together. Page 113. And you had quite a bit of practice with the multiple addends on this particular assignment here. Number 25, page 113 in the homework section. What did you get for your answer, Bryson?
I got 3.
Close. Help. Luciana? -3, right. Because when you add the two positives, you get a positive 20. Put that with your -23, subtract, keep the sign of the greater, make sure we keep the negative there. -3. Let me come back to you, Bryson, for redemption. Number 26.
-28.
They're all 3 negatives, right? So all you have to do is keep the sign all the way through, add them up. -28 is correct. Number 27. Let's go to Corey. What'd you get? Number 27? -12 is correct. Number 28. What did you get, Jalen?
-31.
Michael.
Positive 29.
Positive 29 is correct. Make sure you're following along with me. How about number 29? Back to Jalen for redemption.
Big number.
It is big number.
Positive 142.
Positive 142. Everything in 29 is positive except for that little -4. So you have all those other things to get 146. Then put the -4 with it, you're at 142. How about number 30? I'd call on Griffin, but he's not here. He's sick. Okay. We do hope you get feeling better, Griffin. Ben, what did you get for number 30?
16.
Not 16, Kirsten.
Positive 11.
Positive 11. Notice all of them in number 30 are negative, Ben, except for the 50, right? So we've got a -1, -8, -22, another -8. Put all those together. By the way, thinking of the associative property class, if you've got a -1, a -8, a -22, and another -8, right? There's the positive 50 that's kind of in the middle here. Let's start by getting these together, because -8, -22 gives us a nice, easy -30. Then let's get these two together as well.
-9.
-9. It's like we're grouping them without actually drawing the parentheses. And then let's put that together to get a total of
-39.
-39. Then we put that with the 50. We do our little bit of borrowing. That's where that positive 11 comes from. How about number 31? Back to Ben for redemption.
2.
Positive 2 is correct. By the way, how many of you realized the 14 and 6 make a 20? There's a -20. Those all cancel. So really the only stuff left, -5, +7, +2. Save yourself some work there. Number 32, Kirsten. Actually, you already gave me one. Let's go to Joel. Big ol', I say big, technically it's really tiny, but
-357.
yeah, it's got a big absolute value. -357 is correct. Great job. Number 33, we go to Elaine.
-25.
Bryson.
31.
+31 should have been our answer there. Right off the bat here, Elaine, we've got the 22 and it says -3. If you change that to plus +3, combined that's a 25. The next number is another 25, so there's a 50, and you got a 51 later, so 50 and 51, there's your 101, and you just put the -70 with that. There's the 31. Coming back to you on number 34, what do you get for your answer?
31.
That's also 31, and so that is correct there. Did anyone go 10 for 10? Those were challenging. Anyone get all of them? Wow, a couple of you did. How many just missed one or two of them? Still really good. All right, are there any questions? I talked through a few, I showed a few. Do you need to see something worked out on the board? We got a quiz coming up, remember? Do we need to see one worked out on the board that we missed? Any questions? Let's drop down then to 35 to 42. And they said, without using a number line, which we wouldn't want to do anyway because we're lazy and number lines are annoying, solve these answers. Now, on some of these, like number 38, we got to add the inverse. Number 40, got to add the inverse. Number 39, got to add the inverse. One could argue 37 we have to as well, but I look at it differently, a little bit lazier there. Let's see how we did on these. Number 35, let's start with Elaine this time.
Yeah. -18.
-18, I don't know what that noise was. Number 36, Joel.
-11.
-11, number 37, Kirsten.
-34.
-34 is correct. Number 38, Ben.
47.
+47, number 39, Michael.
-15.
-15, number 40, Jalen.
70.
+70, number 41, Corey.
13.
+13, and number 42, Luciana.
3.
+3. Anyone go 8 for 8 on those problems? Okay, questions on the one or ones we missed? Any questions on those? Remembering we have a quiz coming up in a few minutes. Questions on those? All right, let's drop down to number 43, 44. Just some good review stuff we haven't seen in a while. We wanted the GCF and LCM of 50 and 75, and we might be able to figure this out in our head. What is the biggest number that is in 50 and 75? Think money, class.
25.
25, right? 25 cents is 2 quarters, 75 cents, 3 quarters. 25 is our greatest common factor. If you weren't sure about that, you could do your prime factoring here. And we noticed that the factors are 5, 5, 2. The factors are 3, 5, 5. What do they both got, class?
2, 5.
2, 5. So 5, 5, or 25 is the greatest common factor. LCM, that's the smallest number they could both become. Well, can a 50 become a 75?
No.
What if you double a 75? What's that?
150.
150. Could a 50 become a 150? Then that's your LCM. That's the lazy way of thinking of it. Or you could say, who's the winners? Well, 2's a winner. He's the only one. 3 is a winner. And 2 5s is a tie. So winner, loser. And then we just take 5 times 5 times 2 times 3, and there's our 150. How many had 25 and 150 as GCF and LCM, respectively? Joel, new to us here. Is that something you're familiar with, GCF and LCM? Okay, so that's not a new concept for you then. How about for 8 and 44, Bryson, what is the GCF?
4.
4 is the biggest number that goes into 8 and 44. What about the smallest number they can both become? What about that LCM, Bryson?
80.
88 is correct. 8 can become a 44, but if you double it to an 88, now 8 can become that. Or again, use your prime factors, 2, 2, 2, and 2, 2, 11. Well, the 11's a winner, but the 2, 2, 2 beats out the 2, 2, so 2, 2, 2, and 11 gives 88. Questions on GCF, LCM? Been a little while since we'd seen those. All right, turn over now to page 118. Turn all the way over to page 118, if you would please now. Do the review, 40 to 52. Page 118, the review, numbers 40 to 52. Just another minute or so to be finishing up. A few students already finished. A few more working on their last problems. Just a little longer. All right, for sake of time, pencils down. Even if you're not finished with all the problems, let's check the ones you did get done. Number 40, what did you get for your answer, Ben?
6.
Positive 6. Number 41, Kirsten.
1.
41?
Oh. 2.
2, there we go. Positive 2 should have been our answer. How about number 42, Joel?
Negative 12.
Negative 12. Again, think of that as negative 11. Negative 1 more puts you at negative 12. Number 43, what did you get? Elaine?
Negative 3.
Negative 3, good. I like to look at the negative 1, negative 5, negative 3 collectively as a negative 9. Positive 2, positive 4 is positive 6. Or you might have noticed, well, negative 1 and negative 5, that's negative 6. Positive 2, positive 4, that's positive 6. That all cancels. The only thing left in the middle is the positive 3. Could have done it, or negative 3, excuse me. Could have done it that way also. What about number 44, Jalen?
44. Negative 10.
I'm sorry?
Negative 10.
Negative 10 is correct. Great job. Had to add the inverse on that negative 2 or minus negative 2, make it a positive 2 there. What about number 45, Corey?
Negative 19.
Good, negative 19. In both the cases of minus negative 2s, had to make them plus positive 2s. And then what about number 46, Luciana?
1.
Positive 1 is correct. Number 47, what do we have to add to a negative 8 to get to a positive 2, Bryson? We have to add a 10, very good. Number 48, what do we have to add to a 3 to get a 1? Michael?
Negative 2.
Have to add a negative 2. And then here at number 49, what do we have to subtract from 2 to get negative 5, Elaine?
Negative 7.
We have to add a negative 7.
Okay.
So we have to subtract positive 7, right? We're adding the inverse. So it's kind of a weird reverse way of thinking there on 49. So we have to subtract positive 7 because we know we would have to add a negative 7. Kind of weird way to think of it. Number 50, GCF, 24 and 42, volunteer. Greatest common factor. Biggest thing in 24 and 42, Michael?
6.
6 is the biggest number in them. What's the smallest thing they can both become? That LCM, Jalen?
168.
168, great job on that. We just looked at that a moment ago. Number 51, go and read that for us if you would, Corey.
The temperature on Tuesday in Pittsburgh, Pennsylvania was 13 degrees on Wednesday. 13 degrees Fahrenheit on Wednesday. The temperature dropped by 5 degrees Fahrenheit. And then on Thursday, the temperature dropped another 5 degrees Fahrenheit. What was the temperature on Thursday?
All right, so we start at 13 degrees, then we drop 5 degrees. Well, what is a way we could symbolically represent, class, dropping 5 degrees, using maybe a signed number? Negative 5 degrees. So we have a negative 5 degree temperature change. Then it says it dropped another 5 degrees. Well, another 5 degree change, class, is another negative 5, which means really we have negative 10. Well, negative 10, positive 13, class, gives us what? Positive 3 degrees Fahrenheit. How many had 3 degrees Fahrenheit for that one? Number 52, read that for us if you would. See, Joel.
If Josh biked 15 miles, Brian biked 22 miles, and Aaron biked 17 miles, how many more miles did Josh and Aaron bike together than Brian biked?
Well, first we have to figure out how many Josh and Aaron biked together. How many total did Josh and Aaron bike together, Joel?
15 32.
32. Brian only biked 22, so together, even though Brian won, combined, Josh and Aaron won. How much more, or how many more miles did they collectively bike than he did?
10 miles.
10 miles. How many had 10 miles on that one? Don't know that we necessarily need to use negative numbers on that one per se, but there we go. All right, questions on those? All right, questions on signed numbers? We feel pretty good about adding and subtracting or adding the inverse? Clear, yes, except for a clean sheet of paper and a pencil. Clean sheet of paper and a pencil. Everything else away. Clean sheet of paper, pencil, everything else away. For those watching on YouTube, this is quiz 10 that we are taking today. Quiz 10. Alright, when you get your quiz copy, put your first and last name in the name spot. You want to there. First and last name in the name spot, today's date in the date spot. Today is 1/19/24. 1/19/24, today's date. First and last name in the name spot. 1/19/24 in the date spot. And as you look at the quiz, you might be feeling a little insulted. Like, I could do so much harder problems than this. I know, my gift to you. All right, so shouldn't take you real long. Should take maybe 3 or 4 minutes, but think through these, think through the rules. Be careful, be accurate, use your cover sheets. You may begin. How many are like, I don't mind being insulted? Yeah, I know. Yeah, I got you. I'm lazy too. Finish, turn your paper over, sit quietly. If you're watching on YouTube, you need a little bit more time. Go ahead and pause the video, but students in here are finished, so we're going to press forward. Next thing, in your textbooks, if you would please, page 116. We've worked on adding and subtracting signed numbers. Logically, the next thing to talk about would be multiplication, right? The fast way of adding the same thing a bunch of times. Now, the book gives you some explanation with number lines and all, and next year in pre-algebra, you'll get a little bit more of a why this works. But as a 7th grader, let's keep it simple. Let's not try to confuse the issue. Let's just understand how it or what works, right? How do we multiply signed numbers? There's 2 rules you need to know. What if the signs match? What if the signs don't? And it's really easy. In addition, if the signs are the same, class, we add and keep the sign. If the signs are different, we subtract and keep the sign of the greater absolute value. We keep the winner, so to speak. In multiplication, you don't have to think about winners, losers, any of that stuff. There's this hard and fast rule, and you see this on page 116 in the box that says rules for multiplying signed numbers. Rule number 1, when 2 factors have the same sign, the product is positive. Always. You multiply positive something times positive something, it equals positive something. You multiply negative something times negative something, it still equals positive something. Now again, that's not true for addition, this is multiplication. If they match, always positive. Don't even have to worry about it. And anytime they don't match, doesn't matter if it's negative positive, positive negative, doesn't matter which one's bigger. Anytime you multiply mismatches, it's always negative. Seem pretty easy? So if they match, put a positive. If they don't match, put a negative. Doesn't matter what the values are, anything like that. Unless, of course, one of the factors is a 0. Because if a factor is 0, class, anything times 0 is
0.
And 0 isn't positive or negative. It's the reference point, right? It's the dividing point between the 2 groups. Look at the example problems at the bottom of the page. They multiply negative 5 times negative 6. Well, first of all, class, are the signs the same or different?
Different. Same.
They're the same. Anytime the signs are the same with multiplication, it's always just going to be positive. And then we see 5 times 6 is 30, so positive 30. Seem easy? Look at the next one. 5 times negative 6. Well, first of all, are the signs the same or different?
Different.
Different. So we automatically know it's going to be negative. Okay, now 5 times 6 is 30. So figure out your sign first and then figure out your answer. Look, if you would, please, on page 117, right across the page. I want you to do 1 through 12. Very straightforward. If the signs match, positive. If they don't match, negative. Doing 1 through 12 on page 117. Several people are already finished. How many feel like this is easier than addition? Oh yeah, definitely. More consistent. Just real easy, don't really have to think. All right, number 1, class. Signs same or different?
Different.
Different, so we're going to get negative 15. Negative 15. Look at the next one. Signs same or different?
Same.
Because you don't see them, they're both positives, which means they're the same, which means our sign is going to be positive 21. Look at number 3. Signs same or different?
Different.
So we're going to get a negative 10. Look at number 4. Signs same or different? Same. So we're going to get a positive 27. All right, let's take a look at these now. Number 5, let's go to Elaine.
Negative 18.
Negative 18. Number 6, Jalen.
24.
Positive 24. Number 7, Corey.
0.
0. Not positive 0, not negative 0, just 0. Let's see, number 8, not to insult you too much, Corey. Number 8, what'd you get?
negative 28.
Negative 28. Number 9, what you got, Luciana?
Positive 8.
Positive 8. Number 10, what you got, Bryson?
Negative 3.
Negative 30. Number 11, what we get, Ben?
2.
Positive 2. And number 12, Kirsten?
Positive 90.
Positive 90. How many got all 12 of them right? All right, so not too hard. We feel good about that. All right, any questions at all? Now, what if, though, there's multiple things being multiplied? What if you have multiple factors? Well, let me tell you what we're not going to do. What we're not going to do is multiply one at a time and meanwhile try to keep track of what the sign is doing, because that's annoying, okay? So here's the way it works. A negative changes what you got going. If you multiply by a positive, it never changes the sign. But you multiply by a negative, it messes with things, right? Because you had a negative, multiply by a negative, class, positive, because the signs are the same, right? If you had a positive multiply by a negative, that makes it negative because the signs are now different, right? So whenever you multiply by a negative, it changes stuff. If you had a negative and multiply by a positive, you get still negative because the signs are different. If you have positive multiply by positive, you get still positive. Positives never change the sign of your answer. It's the negatives that do it to you. So if we've got multiple factors, look at the top of the page. Top page 117. They give you this problem. 3 times negative 3 times negative 4 times negative 2. Well, 3 times negative 3, notice, gave them class negative 9 because the signs were different. But then they multiplied negative 9 times negative 4, they got
36.
positive 36 because the signs were the same. Then they multiplied 36 times negative 2, they got negative 72 because the signs were different. So inefficient. Mathematicians are lazy. Besides, we want to use the commutative property. We want to multiply out of order a little bit, don't we? We want to do it the easiest way. So here's how it goes. You only care about the negatives, and you count and add them up. And if there are, let me put it this way, if multiple factors, meaning there's lots of, okay, you multiply lots of numbers. You look at the negatives. If there's an even number of negatives, you have 2 negatives, 4 negatives, 6 negatives, heaven forbid it's that long of a problem, right? But you got 2, 4, or 6 negatives, for instance. You're guaranteed to get a positive answer. You don't have to keep track of the sign as you go or anything. You just know it's going to be positive if you have, class, an even number of negatives. Again, if you have an even number of negatives, you're going to get a positive. If you look at the number of negatives, like, hey, there's an odd number of negatives. Maybe there's only 1 negative. Maybe there's 3. Maybe there's 5. You got the idea? There's an odd number of negatives guaranteed to spit out a negative answer. You ain't got to keep track of it. You just look at it at the beginning of the problem. So what I would do on the blue problem at the top of the page is I'm like, how many negatives do I see, class? 3. Is that even or odd? So is my answer positive or negative? Negative. So I put the negative before I ever do any multiplication. Then I'm like, all right, 3 times 3, and 4 times 2, and 9 times 8. There we go. 9 times 8 is 72. It's okay. It's Friday. All right. Does that seem easier? Instead of keeping track of, now they're the same, now they're different, now they're the same. No, we don't want to mess with that. Look at the example problem, 3.4b. How many negatives we see, class? 3 again. So that's an odd number, so my answer is going to be negative something. I don't know what yet, but it's negative something. But get that down. By the way, that's partial credit. All right, then we look at the numbers. We're like, all right, I'm going to save that 6 because I'm lazy. What's 4 times 3? 12 times 4, 48. Okay, now I'll do the 48 times 6. 6 times 8? 48 carry the 4. 6 times 4 plus 4. All right, so negative 288. That's my answer. Same answer they got. My way was easier. Make sense? So count up the number of factors. And again, they have that in bold there. If there's an odd number of negative factors, the final product will be negative. If there's an even number of negative factors, final product will be positive. By the way, you can actually use this even if there's only 2 numbers. Because if the signs are the same, they're either 2 positives or 2 negatives, right? 2 positives means you have 0 negatives. You could think of that as an even number. If they're negative, that's 2. That's still an even number, still get positive. If it's negative, positive, or positive, negative, it's only 1 negative. That's odd, right? So this actually applies no matter how many factors you have. It's just easier if there's only 2 to think same, positive, different, negative. Okay? Even number of negatives, class? Positive. Odd number of negatives? Negative. All right, so let's take a look now at number 13. How many negatives do we see on number 13, class?
1.
So I know my answer is going to be negative something. Okay, now let's do 6 times 2. 12 times 4.
48.
So our answer is negative 48. Look at number 14. How many negatives?
Even.
2. That's an even number, so my answer is going to be positive something. 2 times 3 times 4.
24.
So my answer is
Positive 24.
positive 24. Number 15. Oh, I see something, class.
And add it
0. So I already know my answer is
Zero.
0. Now, Michael's right. 2 and negative 2 are additive inverses, but are we adding them?
No.
We're multiplying them. So the whole additive inverse thing doesn't matter when you're multiplying. But when I see a 0, my answer is just 0 if you're multiplying, right? Look at number 16. How many negatives?
2.
2. That's
Positive.
even. So we get
Positive.
positive. And then now let's see. 7 times 3, 20 times 21 times 10, 210, stick 0 on the back, right? Look at number 17. How many negatives? 3. That's odd, so negative. And 1 times 1 times 1? 1. Look at number 18. How many negatives? 3 on number 18. 3 negatives is odd, so I'm going to get a negative sum. Let's see, 2 times 2,
4.
then times 8.
32.
32. Negative 32 is our answer. Does that make sense? Figure out your sign first by counting up your negatives, then figure out the multiplication in whatever order you like best. I want you to finish it out now. Do number 19 to 26. 19 to 26. All right, let's take a look at these together, and we'll start with Joel, number 19. What'd you get for your answer?
Negative 27.
Negative 27. We got 3 negatives, so we know that's negative, and then we don't care about the ones, but 3 times 9 is 27. How about number 20? What'd you get, Michael?
Positive 6.
Positive 6. You know it's going to be positive because there's 2 negatives, and then, of course, ignore the 1. 3 times 2 is 6. Number 21, what'd you get, Corey?
Negative 8.
Negative 8. 3 negatives, that's odd, so negative, and then 2 times 2 times 2, ignore the 1 is 8. Number 22, Bryson.
Negative 24.
Negative 24. 3 negatives, that's odd, that's negative, and then 6 times 2 times 2, 24, ignore the 1. Number 23, Ben, what'd you get?
0.
0. It would have been a positive 35 except for the 0, but we just put 0. Not to insult your intelligence, Ben, number 24, what did you get?
Negative 18.
Careful, how many negatives do you see?
Positive 18.
Right, because there's how many negatives?
4.
And that's even or odd?
Even.
Even. So it has an even number, it goes positive on us. Positive 18 for 24. How about number 25, Luciana?
Positive 36.
Positive 36 because there's 2 negatives in class. Number 26?
0.
0, of course. All right. Anyone go, what is that, 11 for 11? Anyone get all 11 correct? Good. Anyone just miss 1 or 2? Questions? Turn the page. Take a look at just a few word problems together here. Read number 36 for us, if you would, Jalen.
Nathan is delivering gasoline to the Exgo gas station. His tanker truck has 5,600 gallons of gasoline. The gasoline flows from the tanker truck at a rate of 150 gallons per minute. How many gallons can he pump out of the truck in half an hour?
All right, so he's got a whole bunch of gas in the tank, right? He hooks it up to the pump the gas down into the ground so you can fill your gas tank. His pump pumps how much gas per minute, Jalen?
150.
150 gallons every single minute gets pumped from his truck. How many minutes is it asking about pumping gas, though?
30 minutes.
30 minutes. It says half an hour, so 30 minutes. What number don't we care about, class?
5,600.
5,600 doesn't even factor into this, does it? That happens to be the capacity of his truck. But we're really focused on if he can pump 150 gallons a minute, he's pumping for half an hour. How much gas is he pumping? That's your seats. Solve number 36. Jalen, what do we have to do to solve?
Multiply 150 times 30.
Multiply 150 times 30. But really, Jalen, I'm not going to multiply 150 times 30, am I? I'm going to multiply,
15 times 3.
what is 15 times 3?
45.
45. And then what am I going to do with the 2 zeros I chopped off?
Put them on the back.
Put them on the back. So, what's our answer, Jalen?
4,500.
You're not wrong.
4,500 gallons.
How many have 4,500 gallons of gas getting pumped out? Now, there is a reason why they mention the truck has 5,600 gallons. Let's suppose this is a small tanker truck and it only has 4,000 gallons in it. 150 gallons a minute, 30 minutes. We would say it has the ability to pump this much, but if there's only 4,000 gallons in the tank, it's only pumping 4,000 gallons, right? Because it ain't got 500 more gallons to pump. In this case, that was just to make sure we knew this truck had plenty of capacity to pump out all that gas. Make sense? Questions on number 36. Number 37, read about Wayne for us if you would. I don't think he's little. Read about Wayne for us if you would, Elaine. I couldn't help it, I'm sorry. Go ahead, Elaine.
Wayne has been monitoring the water level at a local reservoir. He noticed the water level at the reservoir was changing at an average rate of negative 120,000 gallons per week. What was the total change in the water level during the last 7 weeks?
What do you think it means when it says the water level is changing at an average rate of negative 120,000 gallons per week? What do you think that means? Volunteer, Ben?
That it's subtracting from the original amount.
Yeah, it's losing 120,000 gallons of water every single week. How does water go into a reservoir? A reservoir is a collection of water that the city uses so that way you have water for your bathroom, water for kitchens, like the water that runs to you from the water system, they keep in a reservoir, and then of course that goes to the water towers, which goes to your house, right? The reservoir is their reserve supply. It's a reserve of water they use to make sure people have what they need. But where does that water come from? Rarely, in some cases, like around here, we pump it from the Chattahoochee River, and then of course it gets filtered and cleaned and all of that before it gets to your house. But most places, rain, right? And also in some places, this time of year, snow. The snow melts. I've got relatives out in California, and they're far enough from the coast, and there's no rivers nearby. Their water comes from the snow. So as the snow melts, as it rains, the reservoir fills up. And then of course, as people use water, it goes down. And if it doesn't rain, and it doesn't rain, and it doesn't rain, that reservoir level gets lower and lower, and suddenly city officials start getting worried and say, hey, don't water your lawns. Hey, try not to use water between these hours. Let's try to conserve water where we can, because this water, once it's gone, we have nothing. And so he's monitoring it, and every week, negative 120,000 gallons. They need rain, but it says, what's the total change for the last 7 weeks? What do we need to do here to find how much it's changing over 7 weeks, Elaine?
Multiply 120,000 by 7.
Close.
No.
Fix it?
Negative.
Good. Multiply negative 120,000 times 7. Now, class, when we multiply, what sign is our answer going to have? Negative, right? Because if negative means the water level's going down, it would make sense after 7 weeks of this, it's going to be way down. So it makes sense we'd keep the negative. Of course, we're not really going to multiply 120,000 by 7, class. We're just going to multiply 7 times 12, which is 84, and then we're going to stick 4 zeros back on the back. So we have a net change of negative 840,000 gallons of water. That is concerning. Number 38, read that one for us if you would, Luciana.
The temperature has been changing at a rate of 1.5 degrees Fahrenheit, negative 1.5 degrees Fahrenheit per hour. How many total degrees will the temperature change in the next 6 hours?
All right, and this is coming tonight, is we're going to start seeing our temperatures drop again. And so tomorrow's going to be cold. Sunday's going to be cold. I don't think it's supposed to get into the 40s. I think it's supposed to, now again, if you're watching from up north, you're laughing at us right now. But for us, we know that when it gets under 40, that's cold to us. It's not even supposed to get out of the 30s tomorrow, starting in the 20s and into the 30s. Anyway, so the temperature's dropping, and that's what the negative means, right? Negative means it's dropping 1.5 per hour. So if it drops for 6 hours, Luciana, what we got to do?
Multiply.
Multiply what?
Negative 1.5 times 6.
Negative 1.5 times 6. At your seats, do so. And let's see, how much is the temperature changing after, or how much has the temperature changed after 6 hours? And Luciana?
Negative 9 degrees.
Is it Fahrenheit? Surely, because we're in the US of A, amen? We do Fahrenheit here. Negative 9 degrees Fahrenheit. How many thought a negative 9 degree Fahrenheit change? Which means, what if the temperature had been 31 degrees? And then there's a change of negative 9 degrees. What would the temperature be now, anyone? Call it?
29. 21.
27.
22 degrees. 22 degrees Fahrenheit. Anyway, number 39, Kirsten, read it for us.
Natalie is investing $55 each month from her paycheck. How much will she have invested in 10 years?
By investing here, probably that means putting it into retirement, right? Probably $55 a month, put it in the retirement. 10 years later, now, retirement accounts earn interest, amen? So she'll have more than this, but she will have put how much into her retirement account after 10 years. What do we need to do here?
55 times 10.
Now, that says how much will she have invested in 10 years, but she's investing $55 each. Okay, at your seats. How much is she going to have invested over 10 years? Again, this isn't how much she'll have in the account. This is just how much in 10 years she has contributed. We assume that the investment has grown. And if you're thinking, that's not very much, yeah, you're right. It's not that much. But you got to start somewhere, right? Every little bit helps. So what do we end up doing here, Kirsten?
What do we end up doing?
Yeah.
55 times 12.
55 times 12 to get how much per year then? Because there's 12 months in a year, so 55 times 12 says in a year it's this much, but she's putting into retirement for 10 years, so now we need to multiply by...
Times 10.
But really, how do we multiply by 10?
Add a 0.
Stop a 0 on the back. So what's your answer?
$6,600.
There we go. How many $6,600 invested over 10 years? Questions on those word problems? Flip back now, if you would, page 117. Let's get back to these signed numbers. I wasn't sure if we'd have time to get to these or not. I think we do. And we just got to fill in some missing numbers here. Number 27, they have 21 times something equals 210. What would you have to multiply 21 times to get a 210, Bryson?
10.
A 10. How many were thinking 10? Look at number 28. What would you have to multiply by a negative 10 to get a negative 210? What would you have to multiply by here, Michael?
Positive 21.
Positive 21. Why does it have to be a positive?
Because a positive and negative equal a negative.
There we go. We need the signs to be different so we can end up with that negative answer. So since they already have a negative, we got to use a positive. Number 29. They have a negative 4 times something equals negative 60. Think of a clock, or think of a football game. Negative 4 times what gives negative 60? What do we have to multiply by here? Jalen?
Positive 15.
Positive 15. We know we have to multiply by a positive because we need the signs class to be,
Negative.
the signs to be different to give us that negative answer. And of course, 4 times 15, 4 15-minute quarters in a football game gives us 60 minutes. Look at number 30. This one's a little more challenging. You're going to have to do a little bit of math here. What times negative 15 gives 225? What times negative 15 equals 225? Well, first of all, class, what sign needs to be in that blank?
Positive. Negative.
We need another negative, don't we? We need the signs to be the same because our answer is coming out to 225. That's positive. The only way you get a positive is same signs. So if one of them is negative, we need the other to also be negative. But now, how do we figure out what times 15 gives 225? What do we have to do?
You could divide.
We have to divide 15 away, don't we? And what do we get that goes in that blank, Elaine?
Negative 15.
It's a negative 15 there. That was a tough one. How about number 31? This one's a little easier. At your seats. Number 31. What do we got to multiply by a 30 to get a negative 120? I multiply by 30 to get negative 120. Corey?
4.
Well, 4 times 30 gives 120, but if we want a negative answer, we know our signs need to be different. So if they have used a positive, we have to use a negative. So class, we should have negative 4 in that blank. Ooh, number 32. Negative 10 times something gives negative 54. What do we? It is a decimal, isn't it?
5.4.
There we go. But do we want positive or negative 5.4?
Negative.
Positive.
We do want positive 5.4 because they've already got one negative and they want the answer to be negative. So we need to make sure we use a different sign so it stays negative. Negative 54 is produced by negative 10 times positive 5.4. Okay. Are you a question, Elaine?
No.
You got it?
Yeah.
Okay. All right. Anyway, we will stop there for second time. Homework for the weekend. Page 118 to 119. Page 118 to 119. Do numbers 1 to 28 in the homework section. Page 118 to 119, homework. Numbers 1 through 28. Have a wonderful weekend, and when the bell rings, you are dismissed.